NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will master how to rationalize denominators that are sums of 3 or 4 square roots by grouping and using a conjugate. We will learn the idea, then do 2 fully worked examples. Key idea: treat the denominator as 2 groups, call them A and B. Then multiply by the conjugate, a minus B. This turns the denominator into a squared minus b squared. The goal is to collapse to a single radical or even a rational number. Example 1. Rationalize the denominator of 1 divided by square root of 5 plus square root of 2 plus square root of 3. We will group the largest radical alone as a equals square root of 5, and the other two together as b equals square root of 2 plus square root of 3. Multiply numerator and denominator by the conjugate a minus b. This will be square root of 5 minus the quantity square root of 2 plus square root of 3. Now simplify the denominator using a squared minus b squared. A squared is 5. B squared is the square of square root of 2 plus square root of 3, which equals 2 plus 3 plus 2 times square root of 6. That is 5 plus 2 square root of 6. Therefore 5 minus that quantity equals negative 2 times square root of 6. So the fraction becomes square root of 5 minus the quantity square root of 2 plus square root of 3, all over negative 2 times square root of 6. To completely rationalize, multiply top and bottom by square root of 6. The denominator becomes negative 2 times 6, which is negative 12. The numerator distributes the square root of 6. We get negative 1 over 12 times the quantity square root of 30 minus square root of 12 minus square root of 18. We can simplify the square roots. Square root of 12 is 2 times square root of 3, and square root of 18 is 3 times square root of 2. Example 2. Rationalize the denominator of 1 divided by square root of 2 plus square root of 3 plus square root of 8 plus square root of 12. For 4 radicals, we group the 2 middle ones together and the other 2 together. Let a be square root of 2 plus square root of 12, and let b be square root of 3 plus square root of 8. Multiply by the conjugate a minus b. Then the denominator becomes a squared minus b squared. Compute a squared, that is 2 plus 12 plus 2 times square root of 24, which simplifies to 14 plus 4 times square root of 6. Compute b squared, that is 3 plus 8 plus 2 times square root of 24, or 11 plus 4 times square root of 6. The difference a squared minus b squared equals 3, a rational number. We are done. The numerator is a minus b, which equals square root of 2 plus square root of 12 minus square root of 3 minus square root of 8. Replace square root of 12 by 2 times square root of 3, and square root of 8 by 2 times square root of 2. Combine like terms to get square root of 3 minus square root of 2, all over 3. Summary: for 3 radicals, group the largest alone, and the other 2 together. For 4 radicals, group the middle pair together, and the remaining pair together. Multiply by the conjugate of the 2 groups. This collapses the denominator to a single radical or a rational number, and then rationalize any remaining single radical if needed. Great work! In this lesson, we will rationalize a denominator that contains grouped radicals. We'll follow a clean, visual step-by-step method. Here is the problem we will solve. Our goal is to write the expression with a rational denominator and simplify. First, group the denominator as a minus b, so we can use a conjugate. Let a be square root of 5, and b be the quantity square root of 3 minus square root of 2. Then the denominator becomes a minus b. To rationalize a minus b, we multiply by its conjugate, a plus b, which turns the denominator into a squared minus b squared. Step 1. Write the denominator as square root of 5 minus the quantity square root of 3 minus square root of 2, and multiply by the matching conjugate. Step 2. Apply the difference of squares identity to the denominator. It becomes a squared minus b squared. Step 3. Expand the square of the quantity square root of 3 minus square root of 2. Expand the square of the quantity square root of 3 minus square root of 2. That equals 3 minus 2 times square root of 6 plus 2, which simplifies to 5 minus 2 square root of 6. Step 4. Simplify the denominator. 5 minus the quantity 5 minus 2 square root of 6 equals 2 square root of 6. Step 5. the denominator still has a radical. Multiply by square root of 6 over square root of 6 to make it rational. Finally, simplify. The denominator becomes 12, and the numerator becomes square root of 6 times the quantity square root of 5 plus square root of 3 minus square root of 2. Quick recap for intuition. We recognize the denominator as a minus b, then use the conjugate a plus b to create a squared minus b squared in one step. This avoided messy multi-term expansions in the denominator. Our final answer is square root of 6 times the quantity. This avoided messy multi-term expansions in the denominator. Our final answer is square root of 6 times the quantity square root of 5 plus square root of 3 minus square root of 2 all over 12. Example. We will rationalize a denominator that contains 4 radicals by grouping into 2 parts and using conjugates twice. Our target expression is, open parenthesis, 2 plus square root 3, close parenthesis, over square root 6 minus square root 3 plus square root 2 minus 1. We will follow the algorithm shown. First, group the 4 radicals into 2 sums to make a difference of 2 blocks. Step 1. Group the middle pair and the outer pair. We write the denominator as open bracket, square root 6 plus square root 2, close bracket, minus open bracket, square root 3 plus 1, close bracket. Now call the first bracket A and the second bracket B. Step 2. Multiply by the conjugate of the denominator block. That is, multiply by a plus b over a plus b. This turns the denominator into a difference of squares. Step 3. Compute a squared and b squared explicitly. A squared equals the square of square root 6 plus square root 2, which is 6 plus 2 plus 2 times square root 12. That is 8 plus 4 square root 3. B squared equals the square of square root 3 plus 1, which is 3 plus 1 plus 2 square root 3. That is 4 plus 2 square root 3. Step 4. The denominator still contains a radical. Multiply by the conjugate for minus 2 square root 3 over the same to remove the radical completely. This factored form is the clean result produced by the algorithm. Group conjugate once, simplify to 4 plus 2 root 3, conjugate again, and reduce to a rational denominator of 4. You could expand the numerator further, but leaving it factored is both exact and tidy. Recap. 1. Pair the 4 radicals into 2 groups to form a minus b. 2. Multiply by a plus b over a plus b for a difference of squares. 3. Compute a squared and b squared exactly. 4. Multiply by the second conjugate to remove the remaining radical and finish with a rational denominator. We will simplify and rationalize the denominator of this expression, carefully following the exact algorithm shown. Step 1. Multiply numerator and denominator by the conjugate of the denominator, which flips the sign in front of the 4th root term. This creates a difference of squares below. Step 2. Use the difference of squares identity. The denominator becomes the quantity 2 root 3 minus root 2 squared, minus the quantity 2 times the 4th root of 6 squared. Step 3. Expand each square. The square of 2 root 3 minus root 2 is 12 plus 2 minus 4 root 6. The square of 2 times the 4th root of 6 is 4 root 6. Substitute these results into the main fraction. Step 4. Combine like terms below. 12 plus 2 is 14, and negative 4 root 6 minus another 4 root 6 is negative 8 root 6. Step 5. To fully rationalize the denominator, multiply by the conjugate 14 plus 8 root 6 over itself. Step 6. Again, apply the difference of squares to the denominator. 14 squared minus the quantity 8 root 6 squared is 196 minus 384, which equals negative 188. Substitute that result to obtain the final rationalized form. This matches the algorithm exactly. Example. We will rationalize a nested radical denominator step by step following a strict algorithm. Our target is the fraction, the square root of 5 plus the square root of 3, divided by the square root of 5 plus the square root of 2 plus the square root of 3. Step 1. Group the pair square root 5 plus square root 3 in the denominator, so it reads left group plus square root 2. Step 2. Multiply numerator and denominator by the conjugate of the denominator, that is the grouped pair minus square root 2. Step 3. In the denominator, Use the difference of squares. Parentheses a plus b times parentheses a minus b equals a squared minus b squared. Here is the grouped pair, and b is square root 2. Step 4. Expand the square. Square root 5 plus square root 3, all squared equals 5 plus 2 times square root 15 plus 3. That is 8 plus 2 times square root 15. Then subtract 2, giving 6 plus 2 times square root 15. Step 5. Substitute this denominator to get a new fraction. The numerator is the original numerator times the conjugate factor, all over 6 plus 2 times square root 15. Step 6. Rationalize again by multiplying numerator and denominator by the conjugate of 6 plus 2 times square root 15, which is 6 minus 2 times square root 15. Step 7. Apply difference of squares to the new denominator. 6 plus 2 root 15 times 6 minus 2 root 15 equals 6 squared minus the square of 2 root 15. That is 36 minus 4 times 15, which equals negative 24. Step 8. Therefore, the fully rationalized form, following the same order of steps, is the product of 3 factors in the numerator divided by negative 24. Here is the expression we will simplify. We will carefully apply each algebra step and show the result line by line. Step 1. Multiply numerator and denominator by the conjugate of the denominator. The inner pair is square root of 6 plus square root of 2, and we flip the minus square root of 5 to plus square root of 5. Step 2. After multiplying by the conjugate, the denominator becomes a difference of squares, the quantity square root of 6 plus square root of 2 squared minus 5. The numerator becomes the original numerator times the conjugate factor. Step 3. We now simplify the denominator. The square of square root of 6 plus square root of 2 equals 6 plus 2 times square root of 12 plus 2. Then subtract 5. That simplifies to 3 plus 2 times square root of 12. And since the square root of 12 is 2 times square root of 3, the denominator becomes 3 plus 4 square root of 3. We substitute square root of 12 is 2 times square root of 3. The denominator becomes 3 plus 4 square root of 3. We substitute this simplified denominator back into the main fraction. Step 4. We now see the same factor, 3 plus 4 times square root of 3, in both numerator and denominator. These cancel to 1, leaving only the conjugate factor in the numerator. Finally, we usually present the sum of radicals in a pleasant order. Here is the final answer. Recap. We multiplied by a tailored conjugate. In this example, we will simplify the fraction square root of 18 divided by the expression 2 root 5 plus root 3 minus root 2. Our plan is to rationalize the denominator using conjugates in 2 clean steps. Step 1. Treat the denominator as a difference. The base piece is 2 root 5 plus root 3, and we subtract root 2. To remove the minus root 2, we multiply by the conjugate, which is the base piece plus root 2, over itself, so the value does not change. Now, we combine the denominators using the difference of squares. Denominator becomes the quantity 2 root 5 plus root 3 squared minus the quantity root 2 squared. And we also simplify square root of 18 into 3 root 2. Substitute 3 root 2 for square root of 18, and expand the square in the denominator. The square of 2 root 5 gives 20, twice the product gives 4 root 15, and 2 root 5 gives 20, twice the product gives 4 root 15, and the square of root 3 gives 3. Finally, subtract 2 from the difference of squares. Combine the like numbers in the denominator. 20 plus 3 minus 2 equals 21, so the denominator is 21 plus 4 root 15. The denominator still contains a radical. Step 2 is to multiply by the conjugate 21 minus 4 root 15 over itself. Use the difference of squares again. The denominator becomes 21 squared minus the quantity 4 root 15 squared. Now compute the numbers. 21 squared is 441. The square of 4 root 15 is 16 times 15, which is 240. Subtract to get 201. Square of 4 root 15 is 16 times 15, which is 240. Subtract to get 201. Here is the expression. The numerator is square root 3 minus square root 2. The denominator is 2 square root 3 minus square root 2 minus 2 times the fourth root of 6. Step 1. Multiply the fraction by 1 using the conjugate of the entire denominator, which flips the sign in front of the fourth root term. This will create a difference of squares in the denominator. Now, the denominator is of the form a minus b times a plus b, which equals a squared minus b squared. Here, a is 2 times square root 3 minus square root 2, and b is 2 times the fourth root of 6. Next, expand the square of 2 root 3 minus root 2. That gives 4 times 3 minus 2 times the product, plus the square of root 2. This simplifies to 14 minus 4 root 6. Because squaring a fourth root gives a square root, we get 2 times the fourth root of 6 squared equals 4 times square root 6. So the denominator becomes 14 minus 4 root 6, minus 4 root 6, which is 14 minus 8 root 6. So after the first conjugate multiplication, the fraction becomes the product in the numerator divided by 14 minus 8 root 6. To finish rationalizing, multiply by the conjugate of the new denominator, 14 plus 8 root 6. Using the difference of squares again, the denominator becomes 14 squared minus the square of 8 times root 6. That is 196 minus 64 times 6, which equals negative 188. Therefore, the fully rationalized result is the product in the numerator divided by negative 188. We keep the numerator factored for clarity. Our goal is to simplify the reciprocal of the expression square root of 7 plus square root of 5 minus square root of 3 minus square root of 2. We'll follow the exact algorithm shown. Pair terms, use conjugates twice, expand, and finish with a fully rational denominator. Step 1. Group the first 2 radicals together and the last 2 together, so the denominator reads left group minus right group. Then multiply by the conjugate, which is left group plus right group, over itself. Step 2. Using the difference of squares in the denominator, we get the numerator as a simple sum of the 4 radicals and the denominator as the difference of the 2 group squares. Step 3. Expand both squares. The square of square root of 7 plus square root of 5 equals 7 plus 2 times square root of 35 plus 5. The square of square root of 3 plus square root of 2 is 3 plus 2 times square root of 6 plus 2. Step 4. Combine like terms in the denominator. 12 minus 5 is 7, and the radical terms remain. So the denominator becomes 7 plus 2 times square root of 35 minus 2 times square root of 6. Step 5. To remove the remaining pair of radicals in the denominator, multiply by its conjugate, which is 7 plus 2 times square root of 35 plus 2 times square root of 6, over itself. Step 6. The denominator is now a difference of squares again, the quantity 7 plus 2 times square root of 35 squared, minus the quantity 2 times square root of 6 squared. Step 7. Compute those squares. The first square gives 189 plus 28 times square root of 35. The second square is 24. Subtracting yields 28 times square root of 35 plus 165. Step 8. One last time. Multiply by the conjugate of the current denominator, 28 times square root of 35 minus 165, over itself. Step 9. Using the difference of squares one more time, the denominator becomes the square of 28 times square root of 35 minus the square of 165. This evaluates to 215, and that is the final simplified form with a fully rational denominator. Notice how each conjugate carefully removed a pair of radicals without disrupting the structure. This systematic approach works reliably for expressions of this exact type. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.